A modern smartphone can process billions of inputs in the time it takes to blink. It routes signals and executes math bordering on magic. A calculator churning through complex equations is a feat of mechanical efficiency. Yet we recognize it as a tool rather than a thinking entity. If you take that same supercomputing power and task it with navigating a physical room, the limitations of raw calculation become immediately obvious. In a system built on fixed code, a chair moved 6 inches out of place creates an unsolvable crisis. The machine doesn't think to move around, it simply reaches the end of its instructions. Speed, without the ability to adapt, is merely automation. To build systems that could survive in our reality, computer scientists had to move beyond the limits of pre programmed logic. Traditional software operates like a train on a track. It moves perfectly within a controlled environment. But in the chaotic physical world, tracks cannot be laid for every variable. When the path splinters, the system halts, unable to process the deviation. You cannot code a rule for every grain of sand or gust of wind. To operate in the wild, researchers had to abandon the rigid tracks model entirely. Transitioning to genuine intelligence meant replacing hard coded rules with the capacity for dynamic adaptability. On the surface of Mars, a planetary rover navigates uneven, unmapped terrain at high speed, its suspension constantly reacting to the rocks beneath it. Suddenly, a foreign object blows directly across its path. This is a variable the machine was never explicitly programmed to handle. How does a machine survive an unknown threat without a pre written manual? To see the exact answer, we have to freeze time and look at how the system processes the microsecond. Survival begins with perception. The system uses radar and LiDAR to actively interpret the environment, turning raw waves into a map of the world. It translates environmental static into a defined, trackable object. Isolating the obstacle from the background noise is of the landscape. But detection isn't enough. The system must also grasp the context. It has to understand the nuance of what it is looking at. By analyzing how the object flutters in the wind, the AI classifies the threat. It determines this is a lightweight piece of debris, a plastic bag, rather than a dense, damaging brick. That contextual understanding prevents the machine from overreacting. It avoids slamming on the brakes or swerving into a ditch to avoid something harmless. Now, the system employs logic to evaluate its options. Even without a specific debris protocol, it uses reasoning to plan the safest course of action, and the AI determines that maintaining its current vector is statistically safer than swerving blindly into unmapped terrain. We unfreeze time, the internal reasoning now manifests as physical execution, and the machine safely ignores the obstacle. The process doesn't end with the clearance of the threat. The final requirement for intelligence is adaptation. The system logs the interaction and updates its internal model. It turns this novel encounter into past experience, ensuring it can identify similar anomalies even faster in the future. Intelligent behavior requires more than just surviving the unknown, it requires learning from it. These capabilities define the line where basic automation ends and artificial intelligence begins. We can view it as a formula. Intelligence is the sum of perception, action, adaptation, and reasoning. When these elements work in concert, the machine transitions from a system that simply reacts to inputs to one that makes autonomous contextual decisions. It is no longer a prisoner of its original code. It has become a dynamic participant in a changing environment. In this light, the speed of a calculation is a secondary metric of performance. The true measure of intelligence is the capacity to step off the predefined tracks and successfully navigate the unknown. But what happens when we take this adaptable intelligence and apply it to the most specialized fields of human expertise?